Torsional vibrations. You've heard about them. Perhaps you've read about them in feature articles or advertising in trade magazines. Maybe your customers or drivers have made comments calling them to your attention. And if you've ever driven a truck afflicted with the problem, no doubt you've felt them. Most typically, they can be felt and heard throughout the truck when the engine is laboring at low RPMs or under hard acceleration in low gears. Drivers may complain about annoying vibrations in the cab or excessive noise.
We always had a vibration under low speeds, low gears, and under torque. Going around a curve, you could feel it. That's when we could feel it the most.
Aside from driver complaints, torsional vibrations can cause serious damage to driveline components, often wearing out U-joints, splines, and other parts long before their time. This can mean excessive maintenance costs and downtime. In an effort to better understand the problems caused by torsionals and devise workable solutions, members of the Maintenance Council of the American Trucking Association and the Society of Automotive Engineers have formed special committees. The suspension experts at Hendrickson are also hard at work, studying the root causes of torsional vibrations and developing ways to reduce the harmful effects. But before we delve into Hendrickson's work, let's examine some of the causes of driveline vibration. Root causes of torsional vibrations can be classified into three broad categories. They are components, such as the engine, clutch, transmission, suspension, or axles; vehicle assembly, driveline installed angles, suspension slope, or height control system installation, for instance; and applications, such as driving habits, GCW, and operating conditions, to name a few. Diesel engines designed in the last few years using electronic controls can generate immense amounts of torque, 20 to 50% more than the diesels of the 1980s. At low RPMs, where torque is strongest, the power stroke sends cycles of power through the crankshaft, creating torsional waves which continue through the driveline. If left unchecked, these torsionals can damage clutches, gears, and shafts. They will also exaggerate any misalignments in the driveline. Here, it's the U-joints and splines that take the beating.
Within basically a year of service, because the truck usually sits from January to about May, where we really don't drive it. The problems we had, it took out 2 midshift bearings. It also took out 4 U-joints in the very same place, the one before the front pig, and it took out 1 U-joint behind the front pig.
Torsional vibration has contributed a tremendous amount to component failures and loss of drive system reliability. If you had to say over the last 4 or 5 years with changes in the industry, it's probably caused as much as a 40–45% rise in warranty and customer complaints.
As we mentioned a moment ago, misalignment of the driveline can also cause or intensify torsional vibration. This constitutes a separate problem from engine torque, but the two factors together can be a potent combination. The spinning of the drive shaft tubes and rotation of U-joints produce vibrations of their own. If all U-joint angles are correct, or within recommended guidelines, these vibrations are minimal and will cancel each other out when they occur. However, if these angles become excessive, this cancellation will not take place and driveline vibration can result. The key component here is the interaxle drive shaft in a twin-screw tandem. The short length of the interaxle shaft leaves little room for U-joints to adjust as they react to undulations in road surfaces or the application of power. U-joint and axle pinion angles can become excessive, and torsional vibration can result. Maintaining correct driveline angles or geometry is a function of vehicle setup, ensuring proper vehicle ride height and a level suspension. Problems can occur if the ride height of the vehicle is not set correctly or if there is a malfunction in the ride height control valve.
We have proven that small increments, as much as 1/4 of an inch in ride height variation, can introduce vibration into the system that can shorten component life.
Suspension slope can also contribute to improper driveline geometry and poor U-joint cancellation. If the rear suspension of the vehicle slopes excessively, either positive or negative, it can result in excessive driveline vibration. These vehicle setup parameters are usually checked under static conditions when the vehicle is unladen. However, improper driveline angles may also occur under dynamic conditions, for example, under hard acceleration or heavy braking. One such condition is called frame rise.
Frame rise happens when the truck is trying to accelerate. The main support member reacts to the torque at the tires and pushes upwards on the frame. That increases the ride height of the vehicle, and that's what changes the pinion angles, is the increase in ride height.
Approximately 75% of all tractors today are equipped with trailing arm type air suspensions, such as Hendrickson's HAS Series suspensions, which react to torque by allowing shock absorbers to extend and the frame to rise. As the tires transmit torque to the ground, the axles react by attempting to rotate in the opposite direction. This effect, called axle wind-up, forces the axles and frame apart, causing the frame to rise. When this occurs, driveline angles can become excessive and torsional vibrations can result. Maintaining proper vehicle ride height and a level suspension helps to ensure correct driveline geometry and reduces the risk of harmful torsional vibration. When a truck comes in with complaints of vibration, assuming they are not from the engine, we proceed with our diagnosis first by measuring vehicle ride height, suspension slope, and driveline angles. For trucks equipped with Hendrickson HAS air suspensions, you can use Hendrickson's ride height gauge. The gauge is notched and marked so it snugs up under the frame rail and points to the bottom of the main support member. We're measuring the distance between the bottom of the frame rail and the bottom of the main support member. On the forward drive axle on HAS tandem axle suspensions, that distance should be 4 1/4 inches, plus or minus 1/8 of an inch. If your measurement is different, we'll need to adjust the suspension ride height. Next, let's check for suspension slope. Again, using the Hendrickson ride height gauge, measure the height of the rear axle main support member. This measurement must be within plus or minus 1/2 inch of the height of the front drive axle. If the front main support member height differs from the rear by more than 1/2 inch, adjustment is required to conform to specifications. Now for the driveline itself. We will use the digital inclinometer to determine U-joint angles on both drive shafts. Begin by measuring the slope of each drive shaft followed by the slope of both axle differentials. The difference between the slope of the drive shaft and the slope of the differential, where they connect, represents the working angle of the U-joint connecting them. No U-joint working angle should exceed 6 degrees. To determine how efficiently the interaxle U-joints are canceling each other, subtract the working angle of one interaxle U-joint from the other. The closer the resulting value is to 0, the better these two joints are canceling each other. This difference should not exceed 2 degrees. If you measured individual angles in excess of 6 degrees, or a difference of more than 2 degrees between interaxle working angles, they should be brought to within these specifications. Torsional vibration can result from improper driveline working angles caused by excessive suspension slope, incorrect air suspension ride height setting, and frame rise. Hendrickson, the industry leader in suspension technology, has developed an integrated system available exclusively with HAS model tandem axle air suspensions, which minimizes torsional vibration caused by these conditions. It's called the EDGE, which stands for Efficient Driveline Geometry, and it consists of 3 elements. First, optimal vehicle setup parameters to ensure proper vehicle ride height and a level frame. Second, a zero-delay minimum deadband ride height control valve for quick response. Finally, high-torque shock absorbers with a patented internal rebound spring to limit frame rise. This system, properly installed, gives Hendrickson HAS air suspensions the edge in controlling suspension-related torsional vibration. Let's walk through installation of the EDGE. The Edge system includes a precision ride height control valve which reacts quickly to changes in suspension loadings, whether from payload weight or especially handling dynamics as the truck encounters uneven road surfaces.
This is the height control valve that we chose for the HAS Edge system. There's several advantages of this valve over other valves on the market. One of the advantages is that this valve has a very small deadband. Deadband is a portion of arm movement that the valve cannot respond to. Other valves on the market have a larger deadband, which allows the ride height to vary anywhere in that range before the valve responds. Another advantage of this valve is that once you go beyond the deadband, it responds immediately and starts to adjust the ride heights, whether it needs to fill or exhaust the air to maintain proper ride height. And again, the proper ride height is critical for driveline vibration to maintain the proper angles.
The valve should be installed at the forward drive axle, where it is less affected by any slope in the frame. Positive linkage eliminates slop and contributes to quick reaction time. 3/8-inch air lines supply sufficient air volume, which ensures speedy response by the valve and total suspension system. To control frame rise, we will install Hendrickson's high-torque shocks, engineered specifically to restrict frame rise without affecting ride quality. High-torque shocks have an internal rebound spring specifically designed to react only to the forces that cause frame rise. The internal rebound spring resists that force, thereby limiting frame rise. But the spring doesn't affect compression performance, so the outstanding ride quality of the HAS air suspension isn't affected. High-torque shocks are large 1 3/4-inch bore shocks with greater oil capacity and larger seal area than standard shocks. This means outstanding durability and long shock life. The Edge system is required on tandem axle vehicles that have 1,550 pound-feet of peak engine torque or greater, or a drive axle ratio of 4:11 up to and including 4.6. Axle ratios greater than 4.6 require Hendrickson application review and approval. For single drive axle tractors that have 1,100 pound-feet of peak engine torque or greater, Hendrickson HAS single axle air suspension models 210 and 230 require high-torque shock absorbers. The Edge system we've just described is the product of over a year of rigorous product development, testing, and field validation.
We've worked very closely with Hendrickson. Hendrickson has put forth a tremendous effort in the last year and a half to understand vehicle dynamics and how their suspension interacts with the vehicle system. We were able to find that suspensions act tremendously different under torque, under loaded, going down the highway than we had previously thought.
We've had a lot of first-hand experience with Jeff Park, Sean Coleman, and some of the other people at Hendrickson. There's a lot of hands-on efforts to get to the bottom of the complaints, to get them handled, to make sure the customer understands that we want them happy, that we want them out there, want their trucks productive.
Since Hendrickson worked in the truck in December, I was the one that came down and picked up the truck at the dealership, and it was, from me feeling it from before, it was gone. But the real proof was when my drivers, the regular guy, started driving, he said the problem was like night and day. The vibration was gone at that time. And so far, it has not shown up since.
If you're not specifying and using Hendrickson suspensions, take advantage of suspension technology from the experts. At Hendrickson, we're driving the industry in suspension technology.